Alright, here we are back with another video. This is graphing quadratic functions, and we're going to be dealing with things called parabolas, these guys right here, and we're going to be dealing with standard form, and we're going to actually take a pretty long equation or function, same thing kinda, and we're going to put it on the graph. So here's what a couple things I want you to know about. Quadratic functions can be written in standard form. I want you to remember that standard form is a form such as this: ax squared, a is the coefficient of x, plus bx plus c. Ax squared plus bx plus c. They're in this order right here. They're in order with the highest power or highest exponent going first. Also, where a does not equal 0. So I need to have an x squared term in there. If a was 0, then it wouldn't be in this standard form. When we graph this, it's going to be called a parabola. So, a couple things here. What does it look like? Well, the equation can look something like this: y equals x squared, and that's all I have. I don't have the bx plus c. That's okay, because I still have an a. I still have an a here. And if I do have an a, and this is positive, as you can see, positive is in front of the x, it's going to open up. It's going to open up. Down here, where this, the very bottom of the parabola is called the vertex. Now here's one with a negative in front of the x squared, which means it's going to open down, and of course the vertex is right at the very top, right there. Alright, the steps in graphing a quadratic. Remember that y equals ax squared plus bx plus c. A doesn't equal 0, and we're going to make a parabola with it. Our step 1, we need to do something called find the x coordinate. So we're talking about a coordinate of points, an x and a y. We're just looking for this guy first. X coordinate of the vertex. That means, you remember at the basically at the top up here where the vertex was, I'm going to find the x coordinate. I'm going to find the x coordinate for that one. How do I do that? Well, I know this is a little quick formula some genius came up with. X equals negative b over 2a. And of course, that's going to help me find the x coordinate for one of those vertexes, depending if it's negative or positive. Step 2, you're used to doing this, making a table of values of x and y, and use a certain number of numbers. You guys know Mr. Zinn's favorite 5 is, when we were doing linears, it was -2, -1, 0, 1, and 2. Well, this time it's going to be a little different. I need you to start thinking of 3 numbers that are going to be to the left of the x of the vertex number that you're going to find out here, and I want you to get 3 numbers to the right. So you're going to have 7. There you go. You can have 7 numbers in this big table here. The third step is you're just going to take your xy values and you're going to plot them out, and you're going to connect them with a very smooth curve, and that's going to form the parabola. So, here's an example. I want you to graph y equals x squared minus 2x minus 3. Go back to step 1. Let's find the x coordinate of the vertex. And I do need the coefficients of a in here. A is 1. There's a 1 right there, implied. B is -2, -2. And C is -3. To find the x coordinate of the vertex, remember where they come together right here, I only need to know these coefficients. What's b and what is a? B, I'm going to rewrite it. So the negative, b is a -2, right from here, divided by 2 times a, which is 1, negative still. I go ahead and take care of the parentheses up here, and I take care of the parentheses down here, order of operations. -2 divided by 2, all multiplied by a -1, and our result is +1. What does that mean? That means the vertex the x coordinate is going to be a 1. I don't know what that is yet. Okay, a great table here for you to copy down. I'm going to ask you to work out these ones here so that you can get the same results that I do in your notes. However, let's just kind of go through the table here. You're used to doing this with a linear one. Now we're talking about a quadratic. That's got a little exponent of 2 up there. If you remember the 1 from the x coordinate, I put him right in the middle of my table of values right here. And I am going to find out what the y value is for that. But remember, I asked you I want you to have 3 numbers to the left of 1, and so that would be 0, -1, -2. And I want you to have 3 numbers to the right of the vertex. In this case, it's 1. So 2, 3, and 4. Remember, all we're going to do is we have an x, we have the rule, or the function. We're going to plug x in here. We're going to get our y, and then we can just put our x, y solutions together, and we'll be able to plot it after that. Put in, or substitute, -2 right here for the x. -2 squared, also put it in right here for this x. And when you work this out, that's obviously +4, another +4, which is a +8, -3, and that gives you +5. That's how I got that. And so I do that for every single one of these. You have this right here on the video now, so you can copy this down. And you're going to come up with this table of x, y values. So I have a table of x, y values doing the math for each one of the x's, plugging each x in, working it out, and getting my x, y values. I'm going to take these and put them in a graph. Let's find out what that looks like. Okay, I've rewritten my step 2 right here. Here's all my results, all my solutions right here for the graph I'm going to use. So I've got step 3. I'm just going to graph it. So I have my table, and I start off with a plot. -2, 5. I'm going to plot it right there. -1, 0. -1, 0. 0, -3. Where'd it go? Here we go. 0, -3. Start 0, and then I'm just going to go down. 1, -4. Little click to the right, and 4 clicks down. That's the vertex. If you remember, the middle value right there, middle solution, is the vertex. And then I start going back up the other side. 2, -3, 3, 0, 4, 5. I draw the smoothest curve that Mr. Zinn can do. So I'm sure I have some students out there, I've seen your artwork, and it is like awesome. So I know that you're going to have some better curves than I am, but this is what I'm looking for. And the other thing is, I have this little dotted line right here. Seems to just split the vertex. Well, it does. It's actually called the it's called the axis of symmetry. The axis of symmetry is actually the vertical line that splits the parabola, and it splits it at x equals 1. X equals 1 right here, and remember, that's the same thing as an x-intercept. If I was going to graph an x-intercept, remember, that's a vertical line, and so the vertical line right here is the x-intercept. You need to know that. You need to know that that is the line of symmetry, meaning that all the points, you can see the points, they line up perfectly side to side here. So it's like a mirror image of each side. That's called line of symmetry. The same thing on this half, same thing on that half. All right, on to the next video, and I look forward to working with you in class.